like to talk to you about Giovani Poleni and especially focus on his lectures of experimental philosophy that he held in Padua from 1739. Well, first of all, let me recall that Galileo worked at the University of Padua, but for a long time, actually for decades, in Padua as well as in the whole Europe, natural philosophy went on being taught in university within philosophy courses in a very theoretical way. There were only a couple of exceptions of experiment-based courses at the end of the 17th century, one in Paris, for instance, by Pierre Polignaire. These were natural philosophy lectures, thus encompassing all aspects of nature, minerals, plants, animals, as well as hydrostatics, colors, etc. And then, and this is also well known, more specific lecture demonstrations focused only on what we now call physics were proposed from the beginning of the 18th century in England at first, and then in the Netherlands, and then in the whole Europe. And then it is within this context that in Padua, a chair of experimental physics, experimental philosophy, it was called at the time, experimental physics in today's words, was created in 1738. It was actually among the first chairs of this kind that were created in Europe. I would like to say that these chairs were quite a revolution in teaching, because for the first time, courses based on experiments, on demonstrations, were proposed to students. Now, this new chair was assigned to Giovani Poleni in February 1739. Who was Poleni? Poleni he was a very well-known scholar of his time. He worked on a variety of fields. He was regarded an expert in philology, in antiquity, and especially in antique architecture. So he published a new edition of Vitruvius' works, for instance. He was an expert in music, but also mathematics, astronomy, and of course, experimental philosophy. He was a member of the main academies of Europe, so the Royal Society, the Académie des Sciences in Paris, the Academy of Science in Berlin, in St. Petersburg, and he was in touch with dozens of scholars. Newton, Euler, Nicolas, and Johann Bernoulli, Delisle, Celsius, Nollet, Gravesand, Marshallbrook, Maupertuis, etc. Now, what about his role in Padua? Well, in Padua, Poleni held several chairs of astronomy, natural philosophy, mathematics, and then he was assigned this new chair and of experimental philosophy. And I would like to underline the difficulties that Poleni had to face. He was actually very worried about this new course he had to hold, as it was, as I said, a totally new kind of chair, and he wondered how to organize these lectures, the new lectures. So he underlined, for instance, that to set up a new course of experimental philosophy, one needed to know, and this we found in one of his manuscripts in Venice, one needed to know the history of all existing experiments. One needed to know all the details about the way these were carried out, the instruments used, the results obtained, and their actual impact in natural philosophy. Poleni talks in this manuscript of a mare magnum of knowledge that one needed to study and learn about, a mare magnum to which each professor had to add his own new instruments and experiments. Poleni also discussed the structure to choose for his course. Well, there were at the time only very few experimental philosophy treatises, and Poleni wanted to find his own way. So he finally decided to follow what he calls the order of natural and mathematical things. So he starts with statics, hydrostatics, machines, and then optics, etc. And I would like to point out the fact that the reflections and discussions that took place in those years actually gave birth to the structure of current physics courses. Then Poleni had to face very practical issues. Up to that time, most lectures in Padua, as well as in other European universities, were usually held by the professor at home. But now, Poleni needed a place where students could all see the experiments. So a theater for experimental philosophy was built at the historical building of the University of Padua, which already housed an anatomical theater. Then there was another practical problem. Poleni needed an assistant to help me to prepare instruments and handle them during his lectures. And then, of course, he needed instruments. And here I would like to underline that except for England, well, there were not so many workshops that were building scientific instruments in those years in Europe. And with the boom of interest in lecture demonstrations, this boom of interest was not limited only to university, but also to royal courts, salons, etc., private. With this boom of interest, these ateliers were not enough. Scientific instruments were difficult to find and extremely expensive. So Poleni bought some instruments from Marschenbruck in Leiden, from Nollet in Paris, and he bought instruments from scientists and makers in Italy, but he had most of his instruments made in Padua under his supervision by various craftsmen. So he had a blacksmith, a carpenter, and other craftsmen working for him, and the instruments were assembled under Poleni's guidance in Padua. Now, these instruments were instruments for teaching, but also some of them were used for research. So, for instance, Poleni was asked by the Pope, Benedict XIV, to restore St. Peter Cupola in Rome. In this sense, Poleni decided to fix iron rings to reinforce the cupola. And to determine the most adequate cross-section for these rings, he carried out experiments with his so-called macchina divulsoria, an instrument devised by Marschenbruck to measure the resistance of materials. Another example, well, Poleni also used his refractometer, as he called it, to measure the refraction index of liquids at different temperatures. These researches were never published, but we found traces of them in one of his manuscripts in Venice. Poleni also invented several instruments by himself. For instance, an instrument to demonstrate the law of falling bodies, a sort of mercury chronometer that allowed him to measure the velocity of vertically falling bodies. Well, Poleni sent this instrument around. We are currently working on a joint project with the University of Brest in France to study and edit Poleni's correspondence. Well, these are thousands of letters, and only a small part of it has been studied as of now. So from these letters, we learned, for instance, that Poleni sent his instrument for the law of falling bodies to the Pope's special secretary and other instruments to various scientists throughout Europe. Poleni himself sent to and received thermometers and barometers from de Lille, who was at the time at the Academy of St. Petersburg. Well, I would say it's quite amazing to imagine such fragile instruments traveling throughout Europe. Once again, this clearly shows that the diffusion of the new experimental philosophy practices not only took place through books, papers, letters, and travels, but also thanks to instruments that were sent around and exchanged. Well, about Poleni, let me also recall that one of his assistants, Giovanni Antonio Dalla Bella, after working with him, introduced experimental philosophy lectures in Portugal, in Lisbon at first, and then in Coimbra. He is actually the founder of Coimbra Cabinet of Physics. And just a curiosity, Poleni's instruments in Padua are engraved with Roman numbers, Arab numbers, and letters. And I saw in Coimbra exactly the same kind of code, if we can call it like this, on 18th century instruments. So these codes actually gave the position of each instrument in the various cupboards of the Cabinet of Physics. So Dalla Bella in Coimbra organized his collection exactly as Poleni used to do in Padua. Finally, I would like to underline the connections Poleni had with the territory and the local community. So, for instance, he had in his Cabinet of Physics a model of pile driver that was devised and used to reconstruct a well-known bridge of the region in Bassano, a bridge that had been built by Palladio. Now, instruments like this one show Poleni's interest for the practical problems of the region. He was actually deeply involved in researches on environmental issues. So he worked, for instance, on the preservation of woods and forests. And as he was an expert in theoretical and applied hydraulics, he analyzed the path of rivers, canals, their preservation, of course, in relation with the economic needs of the Republic of Venice, the Republic of Venice actually had a long tradition of involving the mathematicians working at the University of Padua in these practical questions. I would say that this is what we call today the university's third mission. Now, what happened at Poleni's death? His Cabinet of Physics had about 400 instruments at the time. His successors went on acquiring new instruments for research and teaching, which continuously enriched the university's Cabinet of Physics. And it is this Cabinet of Physics which finally gave birth in the 1990s to the Museum of the History of Physics.
Se você gostou, deixe o like, compartilhe e assine o canal. Para receber notificações de novos vídeos, clique no sininho.